now. And today we're going to talk about Matplotlib, and we're also going to talk about pandas today. And I think tomorrow we'll talk about machine learning, and also tomorrow we will talk about the projects if we have time. I will probably not go over the pure statistic parts, which you can look at the materials in the materials that I prepared before. And so, yeah, we're going to continue our talk about Matplotlib. Yesterday we talked about, yesterday we have talked about plots, and today we're going to talk about the bar chart and also the pie chart and also probably the histogram. And I'm going to create a new file, and this file is called day 3. And we have already talked about the installation, so I'm going to directly import numpy as mp and also import our matplotlib.pyplot as plt. So if we're going to plot a bar chart, then we need to have some values for our x and y axis. So similar to yesterday, we're going to use the MIT application status. So I'm going to first input the data as a list for the x-axis. So this is a year, this is a class actually. This is a class of 2024, class of 2016, and also I'm going to input the data for the year applications. And then if we want to plot a bar chart, then what we can do is just plt.bar, which is plt.plot yesterday. I'm going to plot the x-axis, and now our y-axis is year received. And year received. And then we need to have the show function always to show up. And I'm going to just plot that without the legend and without the title. So I'm going to show you the bar chart without any other details. So this is the bar chart without any details. Something that I forgot to talk about is that you can like zoom in this chart with like this, and you can save this chart with this, but also you can do save fig function that can save it in the desktop like 1, 2, 3, and you can find that in the desktop. Also, like if you zoom in it, then it's also going to give you the graph that has been zoomed in, but also you can use the save fig function, which is also basically the same. So also do like plt dot save fig, and you can save it as like any name, and you can also like run that to save the fig. I'm not going to save it now. So that's one thing. And also for the bar chart, you also need to have the x label and y label. It's similar to our plot, so we can do plt x label, plt x label. Our x label is just a then I'm going to change this to class. I think it's more precise to say that it's a class. So yeah. I cannot do that as class because class is a object-oriented class, so it will give me a name, like an arrow, so like probably just class year, or just I'm still going to call it year. The reason I call reason that I cannot call the variable class is that Java is Java and Python, and also like a lot of other languages all of them are object-oriented programming. For the object-oriented programming, you have object and you have class. And in the class, you can write several. You can write the constructor, you can write the methods, and you can like instantiate the class as an object. And the only several languages that are not object-oriented is Fortran and also Visual Basics. And I think there's only like 3 or 4 that is not object-oriented programming, that is procedure-oriented programming, but like Python or like Java or like R or Julia, like most of them are just object-oriented. And X label is going to be class, and Y label is going to be probably just called the number of application. Number received, probably. You can call that with more detailed name, and also plt.title. It's similar to what we have done yesterday. Wait, title, application. And we can run it again to show that was our X label and Y label and our title. So I need to admit. Thank you so much. Thank you. And then we can come back to our IDE. And what we can put in is that we can put in more bar, and I'm just going to paste the data because no one wastes time to input all those data. So basically all the data are put in the list, but also, as I have said before, you can also put them in a NumPy array. So this is also giving me other details. I have just pasted what I've. Okay, so I'm going to delete that part because we haven't talked about them yet. And basically, this is just I have put the X value and I put several different Y value. What we can do is that we can just plot different of them, but something that is different is that first we can just like plot that as like just the same as our plot. What we will see is that the things will stack on each other, so they have been overlapped together. So here received and here accepted. Let me plot these two first. You'll see that it's not what we want. So I'm going to plot these 3, software will run, and I need to take time. I'll probably run it again. These 3. So actually they have been stacked together. So it's not our like we can check like our EA received. So we can check that what happened. So EA received and EA accepted. EA received is 6008. So what we want is probably just add the number, like put like EA accepted at the bottom and then stack EA received on the top. So we want to get not like 6008, but instead we want to get 6688 instead. So when the stack this bar on the top of the other, or we can put them side by side. So I'm first going to show how to put one at the bottom of the other, so stack on the top. So I'm going to show my IDE. So if you want to stack one on the other, so probably we're going to so EA received. This is not a good idea. Probably like RD received. So we want to stack RD received on EA received, then we will specify the bottom value. The bottom value should be equals to EA received. So our RD received will stack on the top of EA received if they are from the same year. So we're going to report that. And now you can see that the value has been added together. So it's no longer overlaps together, hiding a part of the bar that is like the bar that plots the first, plotted the second. And we're going to go back to my IDE. But now what we want to do is not only plot received, but also we want to plot EA accepted. So we want to plot them side by side instead of showing a segmented bar chart. We also want to have the side by side bar chart, and this is going to be a little bit more complicated. So first, I have like imported NumPy before because that's something that we really need. And what we are going to do is that we are going to move the bar to a little bit right to the points that it was like already it's like in before, and move another bar a little bit left. And so first we need to define the width. So if we know the width, then we can exactly make them like stick to each other, close to each other, but at the same time, we have like enough space for each bar to stay when they are just close to each other in a side-by-side way. So first we're going to like have a width probably 0.5, and then we need to define something that is x indexes. So basically we're going to just define like the each position for the bars an index. And so we have like 9 years, so we want to get 9 position for them. So we can do it that we can just use the length function to get the number get the length of years, so the number of the position. And because our position start from 0 to 1 to 2 to 3 to 4, like it's actually a int, and it starts from 0 index. So we can create an array, like a array which we have talked about before, like the NumPy array, NumPy range. Create a array that starts from the value 0, just stop before the value that has been put in the parentheses. So yesterday we talked about NumPy.arrange 8, and it's 0, 1, 2, 3, 4, 5, 7. So now it's going to be 1, 2, 3, 0, 1, 2, 3, 4, 5, 7, 8, because we have 9 yet. And then so before we plot x-axis and y-axis, we can put attributes that define the location of that bar. So x-index, and we can also add x-index for year received, and also we can plot our EA accepted, EA accepted, and also our RD accepted. And also we can stack our RD accepted on top of EA accepted. And then if we plot them now, it's not going to give any change because the middle line of each bar is still like stay on the x-axis. But now we need to move them. So we want to move the EA received by half of the width, and then it's half of the width to the right, to the left, and we want the accepted half the width to the right. So now we can let them just stay side by side, but at the same time, they're not overlapped with each other. And since EA received is on top of EA, so RD received is on top of RD EA received. So we are also going to move that half of the width to the left, and for our RD accepted, it's also the same. So I'm going to change that. And now we can plot that. It still have some problem which we're going to solve, but I'm going to plot that first. You can also try them in your repellent or in your other IDE. So it says that there are multiple value for argument button. So yeah, accepted, yeah, received. So I'm going to first do that without that, and then we're going to add wait, I think I know the problem. So now we have to so I haven't delete this. Now it's going to be fine. I'm going to plot out. And something that also I'm going to, so we can see, so I'm going to plot that, and we'll see that has some problems. Oh, so I'm going to also delete the year because year is actually repetitive compared to our width. So I'm going to plot that again. Now we actually don't know the width if it's really the default width. If the default width is L0.5, then we can get with it. But if the default width is not 0.5, the bar will still just overlap each other a bit. So from this graph, we can see that actually our default width is not 0.5. And also something that has been changed is for our X value, it should be 2016 to 2000 to 2024, but now it starts from 0 to 8. So these are two problems that we are going to address. Going to admit people in. So the way that we are going to address the width problem is that we're going to specify the width of our bar. So we can write width equals to this width is the attribute, and this width is the width that we have defined. And we're going to make all bar start with the width equals to width. So we're going to plot that again. So now we can see that the different bars are no longer overlap with each other, but they just stay side by side, but without any space. You can also add a space. If you want to add a space, you can reduce the width of them, but also you can just if you move to left or right, you can just move a bit more than just width divided by 2. Width divided by 2 moves them exactly at the point that they are not overlapped. And something that we're going to change the x value to what we want instead of 0 to 4 6 8 is that we're going to write plt dot text. So plt dot text, and it takes the text. It also takes the labels. Our text is going to be our x index. That's what we're going to replace each with, and our label with each text should be our year. So basically, the place that is our x index is now replaced by the list of years. So it's going to have the x axis that we want. I'm going to run that again. So now we can see that our X label is back to 2016 to 2024. And I'm going to go back to our IDE. And we can also do a legend for them. So we can label them. We can label it as year received. And label this with year accepted. And also it's same for this two. And label them. And then we can also just plot our legends. And also at the same time, we can also just specify the color of them. So we can specify them to like blue, color, medium, purple. Hopefully we have this color. And also can have color salmon. I have color aqua. I think we have aqua. So we can plot this color. And also we can plot our legend. So this is the result we get. We can also change that to other color, and I'm going to share that back to my IDE. And now I'm going to show you the pie chart. Since something that I can also show you before that is, we can also like, I think I'm not going to show that, but you can just see that from I'm going to like just copy paste it and show that instead of just type them out and show that, because it's kind of repetitive. You can also add the bar chart on our bar chart. So this is going to also be fine. So you don't need to only have bar chart in your program, but you can have multiple different type of charts, different type of matplotlib charts together. So this is my day 3, and I'm going to pause that now. I think it has some problem. Year received, year accepted, markers. So not really sure what the problem was, but I think I probably named something with different name. I think I'm going to just plot everything, just copy everything here to show that, because I have probably like changed the name of them. Oh, I have actually changed the number in received and accepted, and that's the problem why like when I just try to like add my old data, we have a problem with it. So that's like basically you can plot the plot chart and also the bar charts together. And I'm going to share back to my IDE. And after that, I'm going to show the pie chart. And for the pie chart, we can also just use the data of EA received. Fine. We can also use that as the list. So it's like we're going to see if we have like all the people who have been put in the EA, what's the percent of them like in each year? It's like kind of strange, but we can just use that to demonstrate the pie chart. So for pie chart, you just need a list of data and just do pr.pie and then you can plot that. Although still you're not going to have the title if you plot in this way. And something that you also need to add is plt.show to show the data always. So basically, without legend title, it's just going to be a colorful pie with different proportion with default color. And after that, you can also add different name. So first, I'm going to like add a name for each proportion. So I'm going to change some data to make it more sensible. So I'm going to change that to the name and the data that I've propelled. So that's like among the 7 top language, the proportion of them. So it's not like the proportion of all the language. If you add them together, it doesn't equal to 100, and it doesn't really matter. So it's just a relative proportion. It does not need to like add to 100. And now we can plot them. So we're going to plot the proportion. It's going to show our proportion, but at the same time, we can label each proportion with our labels equals to our name. And now we plot that. It's going to make more sense instead of just like a colorful pizza. It's a bit slow for my laptop to run the data. So now we know like what each proportion stands for, and then we can go back to our IDE. So what we can also do is that we can add a shadow to our table. You can say shadow equals to true. And what we can also do is that we can do like which props. We can do like different colors. And I'm first going to just add the title to it. PLT.title, and this probably the most popular language proportion. And now I'm going to show that it's just the same. And when shadow equals to true, you just that you can have a shadow on that. And also, when we want to just choose them for different color, we can just make a list of color. And the list of color should have the same, like, you can just make them all in one color, like color equals to red, but also you can just give each of them different color. So red needs a parenthesis around it, a quotation mark around it. So I'm going to run this first, and then I'm going to show that can have different colors. It's a bit slow to run them. I think probably use repellents to run. I don't know. Yeah, I think it's not really good to run Matplotlib with repellents. I think I always have some problem with that when you want to just run that with Matplotlib. Color arguments. Wait. I think it should be colors. Yeah, it should be colors because you can just let all color equals to one color, but pie charts is usually propelled for different things have different color. Otherwise, without which prop, which I haven't said our which prop equals to line, it's going to be really confusing. Now it looks like just like a pie without anything. So I'm going to just put a list of color. So I'm going to put a list of color. I'm not going to type each color. I'm going to also copy paste some color. So I have 7 values, so I'm going to have 7 colors. And then for my colors, I'm just going to put colors. And now we can run that to see the effects. So now it's going to look much better. And actually this 7 color is a color for the Nature magazine. So if you like, if you conduct a research in the future, then if you want to submit a paper to Nature, then you need to use its specific color. And Nature is a really nice magazine, which is like super hard to, like a journal which is super hard to be accepted. So, but that means your research paper is also really great. And another thing that we can do is that we can explore the portion of the pie out. So just like you can take a piece of pizza out without like scatter all the piece of pizza. So what you can do is that you can do explode, and now we have 7, so we also can do like 7 of them. So we can explode Python, we want to explore Java a bit, and we don't want to explore JavaScript, don't want to explore C, and don't want to we can probably explore pipe, and we don't want to explore R. And now we can add explodes. Explode equals to our explode. So we can see now it's just like we take out some piece of pizza. And we have take Java most far away from its center, Python most far away from its center, but Java and PHP is basically much closer because it's just 0.1 far away from our center. And also what we can do is that we can just label the proportion, the exact proportion of each piece of pie. So what we can do is that we can do auto poke. So we can put that here. So auto poke. And then it's just like our string format, which I haven't talked this time. So basically, you need to add the percent sign, and inside the percent sign, you're going to like specify what it's going to be. So I'm going to put 1.1 F percent. So that's going to give me the percent sign was, wait, why is my name? So why this is giving me an arrow? So yeah, I also need to code a quotation mark around it, just like our format, and quotation mark and then percent sign, and then this is going to specify that I want the label to be like 40.4%. So that's like the part that has been specified. So here 1 just means that we only have 1 digit after the we only have 1 decimal place. So I'm going to show you. So our result only have 1 decimal place, but also if you want to let it have 2 decimal places, you're going to put 2 instead of like this way. This is going to give you 11 decimal place. So I'm going to make like 1.3 to show you the effect. 1.3, it's like 3 means 3 decimal place. It's not means like 3 means only 1 decimal place. So this is showing like 3 decimal place. After that, we do this. So I'm going to go back to my IDE. And also you can also like do which color. I've also showed that. Also you can do for the which color for the which props. You have like the hatch, which hatch give you like the shade, different shade with different like shape on it, and also the which has a line, so the line also have its line style, and like I have like just draw a like red pie, but if you want to divide that, then you can just specify the which box has the edge color, which equals to like black or the line style, and also at the same time, you can also like enlarge this pie, and also you can just turn that by like certain degree. So by enlarge that, you will use radius. So the default radius equals to 1.1, equals to 1, and you can like let the radius equals to 1.5. Also, you can just adjust the distance of the auto plug. Use plug distance, so PCT distance, and I've shown all of them in my in the file, so I'm not going to restate them. And now I'm going to talk about histogram briefly, and then we are going to talk about pandas briefly because we are running out of time. So I'm also like going to just copy the data because it's just so hard to type a lot of data. And it's going to use plt.hist for histogram. And so we can also still do the X label, Y label, and the title. Then we can just run those to show this histogram. And we can see the default number of bars, so the default number of our bracket. You can also say that. So I'm going to plot that. So now it also does not have the wedge. So basically they are connected together. It looks a little bit confusing. So what we can do is that we can specify the host. We can specify its edge color. So we can have an edge color equals to black. Now it is not going to be that confusing, just like everything being together. I'm going to put black in the quotation mark. Now we can see that it has 1, 2, 3, 4, 5, 6, 5, 6, 7, 8, 9, 10 bars. So that's our default number of bars or bins. Bin just means like we can have like 5 or 10 places to put. So now we have 10 bars, but also we can specify the number of bins. So we can specify that to be like 3 bins. And we can rerun that. Now it's only going to give us 3 bins. And what we can also do is that we can just specify the range of bins instead of just specify the number of bins. So you can create a list. So we want to go like from, we don't need to like get each value, give like assign each value in the minute of being a range. It can be just excluded from the range that we want. So although we have 7, let's start our range from like 20, 30, and then it does not need to be equal number, equal size of range. We can do like 30 to 15, and we can do like 55. We can do things like this. So we can plot it. I haven't put things in bins. Okay, so we can run that and we can show that. So we have 3 bins because we have 3 rounds and start from 20 to 30, 30 to 50, and 50 to 55. So we can try that out to put like different number of bins, and we can also change the color. Just use color, and I'm not going to talk about that because we have talk about color all the time. What we can also do is that we can change the orientation. So we have vertical or horizontal. So we can do first we can do like horizontal. So this is going to just switch the x-axis and y-axis. This is not making sense now because if we switch that to horizontal, then our x label and y label should also be changed. So you can just simply swap the x label and y label. I'm not going to do that because it's simple. And our default one is just the vertical one. And then I'm going to talk about the scatter plot also. So I'm going to also just I'm going to also just like put data here. So I'm going to just download the CSV, and this is also something that I'm going to show pandas. So I'm going to download the CSV. I'm going to download data for me first, and you can download, like, if you want to find data. First is that you can search that on the website, and probably you can find them in the formats of CSV or in Excel, and they can be read by pandas, which we will talk about later. And also you can print the results into the Excel by yourself, and then you can just save that as an Excel file. But also when you like save the Excel file, you can also save that as a CSV. So I'm going to show my Excel. Where is it? So like so this Excel has been saved as CSV. You can also like just create a new file. So also like our also like the CSV file that we downloaded can be like automatically opened by our Excel. So we can like print value here. So we can put like A, B, wait. We can put A, B, C, D, and E, and we can put 1, 2, 3, 4, 5. And here we can just put some random things like Python. Yeah, probably just random thing. And we can both just simply save them. So save as, going to show my desktop for that. Probably going to, yeah, I'm going to show my desktop because it's not showing it otherwise. So basically you can save that as an Excel form, but at the same time you can save that as a CSV. So here the CSV, you can save that as .csv. You can give it a name like probably this name is, just like this. This is easy for us to import. We can save that as the desktop. And now we can see that I have just downloaded data like this. Also I have like just save the data, like this. And you can say, like, if you want to like search for data, you can search like the data in data.gov, and also you can find a lot of data there. And so I'm going to show it's a little hard to show different software. So I'm just back here, and what I'm going to do is I'm going to just drag my a CSV that I've downloaded here. So I just drag the file to this, and it showed me like I need to save that. So I save that, and then what I can do is that I'm going to first import Panda as PD, and then I'm going to show the scatter plot, but at the same time, you can see a Panda read, so it's part of the IO function. You can read CSV, but also you can see that you can also read Excel form, read Excel is also fine, and also like JSON, also HTML, and also SQL, so you can read them. But now I'm going to read our CSV, so just Panda read CSV plus the name of the file, and I have already put the name of file in the same package. And then this is just getting our data. So for the CSV, we can just print that, we can print this data out first. It has different columns, and if you do this, it's going to like get the data in the view column. So we have like this is our data. So our data basically have 3 columns: view count, lax, and ratio. And if you do data and put a bracket and just put double quotation mark or single quotation mark and of the header of the column, like view count, then this view count is going to store the list of view counts column, so it's going to store the value in this column, and for data likes, it's going to store the value in this column, and also for data ratio, it stores the value in this column. And then for the scatter, so for the scatter, first we can just do view count, and I'm going to and for the CMAP is just about what's the CMAP I'm going to show you in our graph we plot. So I'm going to report that. So here is, so wait a second. Here is here is what we have been plotted. So view count is our X value. We have just put view count in our plt.scatter and put likes as our Y value. And this is like when we have different we have different data, we have different column of data, and according to the value in each index, we have like the corresponding view count and corresponding likes is going to locate in this graph. And our column map is like this is our column map. Its default is from dark green to lower green to like yellow to yellowish color. You can change the color map. You can change that to a lot of, so now it's summer, but also we can change that to, I think we have like green. And I have also put like different data on, so we don't have green, but I think something is related to that. So I have put color map in my file, so you can check that out. So I think, I don't know what color we have in all of it. I can try that out, and also I'm going to refer to the document to see like what map do we have. Okay, so actually I think we can see that here are the CMAPs. So it print out an arrow for grayscale, but at the same time, we can see that here are all the color maps that we have. We have green, so I think it's because I'm not capitalized it. And also we have like purples. We have all this random, like from different companies. We can try them out. Actually, we can try Inferno out, because I have tried that before. So now it's working, and I can share that. So this is a color map. It has the defaults like darker and much more shallower value. And also, actually, we can change the center size of our dots. So now I have just a lot amount of data. So probably it's hard to like, probably I'm going to, so we have ratios and we can actually make the ratios different size of different size of it. So we already have color. We have make color the ratio, and also we can make. We also have size. So we can also let our size become the value of the ratio. And now for different points, it's not all in the same size, but it's going to have different size. So our ratio is pretty much similar. So the effect is not really dramatic, but it still looks the same. So probably I'm going to try likes. Make our likes also the size of it. Oops, this is getting, some likes is just too large, so has been a little bit tricky. This figure has been really tricky because the size of the like is so great that they just overlap together, becoming really confusing. But this also showing that we can really like change the size of our each point, each bubble, and that's also another point of a scatter plot. But then I'm going to talk more panda, so I'm not talking about matplotlib now, but I'm going to focus on panda in our last few minutes today. So I'm comment out the CSV first. Probably we're going to use that again later. I'm going to just delete them. So first, for our panda, we'll create a series. So we can just create panda series by s equals to panda series, and it's kind of similar to create a array or create a list. So we can put like different things in it. We can also like put numpy value in it. So for example, in one numpy is np, then we can put like numpy value in it, and also you can put the list, can put a float, and what we can do is that we can just print out our s. So we're going to have a panda series. So panda series, the difference is that it's going to give each of our value an index. It's going to show in this index with the value that we put in the form of a table. And for our panda, we have the date function. So basically, what I can do is that I can do dates equals to panda.date, and we can set a range for that. So we can start from like today. So it's 2020, 2021, 0207 today. And then we can just say like how many periods do we want. So we want like 10 periods, then we can print the date out. So like date frame, so data frame and also the timestamp, they are the special characteristic for our panda. So now we have 10 times. And also what we can do is that we can just create a data frame. So for our data frame, we can just do data frame equals to panda and then data frame. Data frame is really important for our panda, and inside of it, we can just create some random numbers. If we want to create random numbers, then we can use our numpy function. So numpy.random dot round, and then so we probably like we want have like 10 of them, and then we can have like each of them we have like four random value, and then we can do our index. So our default index is just going to be 0, 1, 2, 3, 4. But so we are first going to like print this out to see our default index. So let's run this. Wait. I also need to like specify our column. So our columns is going to just equal to like we can have a list. This list is just going to be like A, B, C, D. So can try to bring that out. It's also not working because random does not have round function. It says, oh yeah, I just forgot the M. That's a problem. Okay, that's the problem with it. So we can see that we print out the default index. We can also just not having this column. So yeah, so we are going to have our default column name and default row name. So index default default index and default column. If we do not put the value that we want, but we can specify our column like this way, column list A, B, C, D. So this list is actually like much more concise than like we put a list like A and B and C and D. And also we can just make our index into our dates that we have been created. So now we're going to replace our index with our date. And that's something that we can do. And something that we can also do is that we can just get the different data in different ways. So first we can get like the front view line of the data. So we can do like data frame hat. Then it's going to like get all of them. However, it's kind of like slicing. You can like get like 3 of them. Like the front 3 of them. You can get like the front two of them. And you can also detail, and it's similar. You can do all of them, then it still give you all of them. It's like we haven't sliced that, but we can get the like tail 2 of them. So now we are getting the tail 2 of them. And also what we can do is that we can get the index of our data frame. So we have just give our index the time. Now we can print that out. So it's going to print out our time. So it's getting our time now. And also we can print out the column name since we can print out our index, which is just our row name. So we can print out data frame dot columns. And now it's printing out our column value. And what we can also do is that we can actually just convert all of our value in our data frame to a NumPy array. So what we can do is just data frame to NumPy, and now we can print them out. So now it's in a NumPy array. And what we can also do is that we can like describe our data. So describe. So describe is basically helping us to get a count. So we have like 10 counts in each, like in our, we have like 10 rows in each column. So our count is 10. The mean is just in each column, what's the mean value of all of them, standard deviation of each column, mean of the minimum value of each column, the 25% value. So it's just our Q1 first quartile, and our median, our 50% is just our median, and now 75% is our third quartile, and then we're going to get the max value of our data. So it's really like easy for the statistic use. So in statistics, we know like if it's like first quartile, it's like between like 25% and 75%. That's like, this is our first quartile, this is our third quartile minus first quartile, that's our interquartile range, and our first quartile minus 1.5 times the interquartile range, and our third quartile plus 1.5 the interquartile range. If it's between them, then it's not an outlier, but if it's like not between them, then the value is going to be our outlier. And also, what we can do is that we can transpose the data frame. So I'm going to do data frame transpose. And also we can like sort them. So this is going to transpose them. And also we can like we can sort our data. So print sort our data. So we can like sort the data according to our column. So if its axis equal to 0, that means our row, our index, our like row that has a symbol by index. If its axis equals to 1, that means our column, because our index, our like row index is our like 0 dimension, and our column index is our first dimension. And we can specify like whether it's like in an ascending order or descending order. So we can specify ascending to be true or false. If ascending is false, then it's in descending. So like we are now saw that like in different, like it's like A, B, C, D, but now it will become like C, D, C, B, A, and also we can just sort by our column. So we can sort it by sort the values by our column A, for example. So about our A, so now our A is in like, this is the smallest value, this larger value, and it's in a like ascending order. Also, we can do like ascending equals to false, then it's going to sort in a descending value. But B, C, D is not in a order, but B is just what the corresponding B was our A. So this is our sort, and that's like basically what we have time to talk about today. So tomorrow probably we'll talk about machine learning, or we'll also spend some time on pandas. So thank you everyone for being here. Thank you so much. I'm going to I'm going to start the recording.